Project 2.2.3, ISP.Long, the Digital LockSafe. The Digital LockSafe is a custom electronic safe designed to securely store valuables. Access is controlled using a 12-bit binary password and a servo motor which physically locks and unlocks the door. In addition to the locking mechanism, the safe features a multiplex display system that indicates whether the safe is opened or closed.
At the core of the safe is a digital password system built entirely out of logic gates. Each password bit is stored in an SR latch, which retains its state until a master reset is pressed. The stored password is then compared with the entered password using XNOR gates, or equivalence gates, acting as a bitwise comparator. Then the results are cascaded down an AND gate ladder. Only when all 12 bits match does the system output a high signal on the state pin. When the state pin is high, pressing the open and close button will move the server to an unlocked position. When the state pin is low, pressing the open and close button will move the server to a locked position. Here's an example of me using the safe. I'll start by pressing the password to 2051, which is these buttons in binary. Then I'll shut the door. I'll press the open close button, which will lock the safe because the stored password and the entered password do not match. I can no longer change the password or reset it because the door is blocking the buttons from access, and the flat back here also blocks the buttons from access. Now I'm going to enter the password. Let's say I enter a wrong password. So 2049. It won't open. Now I'll enter 2051. I press the button. It opens. I can now retrieve my valuables, and I can also hit the reset button to make a new password. Here's the exact same scenario in Falstad. I'm going to set the password to 2051. I'm now going to input 2051. And the high signals from the bitwise comparator cascade down to one high signal on the state pin.
The multiplex display system uses three 14-segment common cathode alphanumeric displays. The Arduino Nano controls these displays with two 595 shift registers, which allows for 16 bits of data to be latched and output in parallel. The display works by multiplexing and persistence of vision. By serially monitoring each of the 6 transistors controlling the displays, it is clearly shown that each NPN transistor is turning on and off one at a time, but fast enough that the naked eye can't see this on the display. The display brightness is also adjustable with this potentiometer. The Digital LockSafe PCB was designed on Easy EDA. It functions the same as the breadboard prototype, except it is much more reliable due to careful routing and consistent voltage across the circuit. The safe's case was designed in Fusion 360. There are 5 components here, which include the main safe, door, hinge pin, rectangular flap, and custom servo horn, which serves as a more reliable locking mechanism. Finally, onto the code. Here's the code's main loop. Firstly, the state pin is red. The servo rotates to the open angle and displays the word opened if the state pin is high. If the state pin is low, the servo rotates to the closed angle and the word closed is displayed. This only happens when the open close button goes from low to high. For each display cycle, all transistor control digits are turned off. The segment data for the current letter is shifted out onto the registered and latched. Then the corresponding transistor is turned on. This repeats for all 6 letters to create the illusion of a steady display using persistence of vision. Finally, the Arduino reads the potentiometer voltage and scales it to a PWM value and uses it to adjust the brightness display dynamically.